Okay, I'm going to go over the entire review and try to explain it as well as possible. And then I'm also going to give you guys this answer key that I create here, and I'll give it to you today, or it should be on Monday. So, in this first part, this is called function notation. It's where you see f of x and g of x. Now, down below, you see a bunch of different things. It says f, g, and g. Okay? What that means is it tells you which function you're going to. So if you see an f function, it goes to the f. If it's the g, you go to the g function. Okay? Now, what you see the difference is here this has an x, and here this has a 4. That means every time we see an x, we replace it with 4. That's all this means. So in this first one, it's going to say 3. Instead of x squared, we're going to have 4 squared. So we're just going to do 3 times 4 squared plus 8. Now, we're using PEMDAS for this entire thing. Okay? If you don't have a variable, then you use PEMDAS. So first parentheses, well, there's nothing to do in the parentheses. So we can go to the next part, which is exponents. Well, we do have an exponent. We have 4 squared. So 4 squared is actually 4 times 4, which is 16. So you put 3, 16, plus 8. The next letter is m, that's multiplication. So now it's 3 times 16, so that's 48, plus 8. Then we go to division. Well, we don't have any division. Then we go to adding and subtracting. Well, we do have adding, so it'd be 56. Okay, because 48 plus 8 is 56. Then with the negative 2, same thing, it's an f, so we go to the f function, so that means we replace x with negative 2. We square it, we add 8. Always do this, so negative 2 times negative 2 is a positive 4, plus 8. 3 times 4 is 12, plus 8. And finally, 12 plus 8 should be 20. Now onto this one. Now we're going to the g function. So g. Instead of x, we're going to write 5. So this x squared becomes 5 squared. Plus, this 4x becomes 4 times 5. Minus 9. We do the same order of operations. Parentheses, well, there's nothing to do. Exponents, so it's 25. Plus 4 times 5, minus 9. Multiplication, that happens, that's 25 plus 20 minus 9. Do this, so that's going to be addition, so it's going to be 45 minus 9. Last but not least, 45 minus 9 is 36. This one we're doing negative 3 squared, so it's going to be negative 3 squared plus 4 times negative 3 minus 9. So once we've replaced the x, all we have to do is solve. So negative 3 squared would be 9 plus 4 times negative 3 minus 9. 4 times negative 3 is negative 12, so it's going to be 9 minus 12 minus 9. When you do all of this, you should end up with negative 12. That's how you do these. The next part. It's asking you to find the domain and range of each, then determine whether it is or isn't a function. So remember on this first one, domain means x's, range means y. So I'm going to label all these X and Y. Okay. So the domain is all the X's and range is all the Y's. The only catch is that the domain needs to be all the X's in order from least to greatest without repeating. So we have a 3, a 7, a 2, a 4, and a 9. None of those repeat. So we're going to do it from least to greatest. The smallest number is a 2. Then it goes 3. Then it goes 4. Then it goes 7. Then it goes 9. The Y's, the range is the same way. We least from greatest without repeating. 4, 4. -6, -7, 11. Well, the 4's repeat, so I'm only going to write the 4's once. So the smallest number is -7, then -6, then 4. Remember, I don't write the second 4, and then 11. So now all I got to do is, you see how 3 and 4 are connected because they're at the same point? 7, 4, 2, -6, 4, -7, 9, 11. All I'm going to do here is take wherever I see a 3 on the domain, I'm going to trace a line to the 4 on the range. So 3 to 4, 7 to 4, 7 to 4, 2 to -6, 4 to -7. Oops. And then 9 to 11. Now, we are only concerned with the domain side. Do any of these have more than one line coming off of them? Nope, they all have exactly one line coming off of them. Because they only have one line coming off the domain, it's a function. Let's do the next one. Label all the X's and Y's. Alright. The domain is least to greatest without repeating. So we have 4, 2, 11, 6, 2. Well, the 2's repeat, so I'm only going to write them once. Goes 2, 4, 6, 11. The range is from least to greatest without repeating as well. That's 9, 5, 8, 5, 3. The 5's repeat, so we'll only write them once. So it'll be 3, 5, 8, 9. So now we're going to connect things. 4 to 9. So 4 draws to 9. 2 draws to 5. 11 draws to 8. 6 draws to 5. And 2 draws to 3. Now remember, we only care about this side. Is there any of these numbers that have more than one line coming off of them? This 2 does. It has one going to the 3 and the 5, so this is not a function. It's not a function because 2 has more than one y. Okay. Now these next parts are easier to find the domain. Whether or not it is a function or not, but it's harder to tell what the domain and range is. This first one is not a function. The reason is it doesn't pass the vertical line test. If I draw a vertical line right here, as you can see, if I draw a vertical line right here, it touches in more than one spot. it actually touches in a bunch of spots because it's actually following the graph in that part right there. So it's not a function. It fails the vertical line test. Now for the domain and range. Okay? So, domain. What you always have to ask yourself is the domain, is it going left and right forever? Well, it doesn't go left forever. So what's the farthest? We're looking at the x-axis. Where's the farthest it goes left? So if you see right here, it goes farthest left right here. So it goes 1, but it does go left forever. So you see the arrow, it's going that way forever. So it goes into infinity. Range, same thing. Does it go down forever? This one's up and down. Well, as we can see, it doesn't go down forever. The farthest down it goes is actually also 1. But does it go up forever? Well, yes. We have an arrow that's pointing up right here, so it does go up forever, so it goes off into infinity. This next one. Could we draw a vertical line anywhere and it passed through this little curve more than once? The answer to that is no. So it actually is a function. The domain, okay, the domain is we're asking, does it go up forever? Does it go left forever? Does it go right forever? Right here, what you can notice is that this is going down and to the left. Okay, so it's both going down and left at the same time. It's like if I drew an arrow that's pointing right here. It's a little bit more curved like than that, but still, if I drew an arrow that pointed like this, it would be going down and left forever. So, is it going left forever? Yes. So it goes into negative infinity. Next question, does it go right forever? Well, this one is going up and to the right, so it does go right forever. Range. Is it going down forever? Well, yes, because it obviously is going down. Is it going up forever? Yes, it's going up forever. So that's the domain and the range. Finally, this part right here. Is it a function? No, because it fails the vertical line test. Okay. Now domain, it's asking, is it going left forever? Well, we have no arrows pointing down and to the left, up and to the left, or anything like that. So it actually stops right here. So no, it goes up until 0. Does it go right forever? Well, obviously there's 2 arrows pointing to the right, so it does go right forever. Range. Does it go up forever? Well, it's a little hard to tell, but this is going up and to the right, up and to the right, so it does go up forever, so it goes off into infinity. Does it go down forever? Well, this is going down and to the right, so yes, it does go down forever. So that's the domain and range of those. Okay, so when solving these, 3 easy steps. Step 1. Get absolute or square term by itself. So what that means is to get these absolute value signs by themselves. or this x squared by itself. So I'm going to do that on the first one, and then I'll go to the next step. I'm going to first add 6, because you always do adding and subtracting before you do this multiplication part right here. So then you're going to get 3, absolute value of 2x plus 4 equals 24. The next part is to get rid of that 3. So we're going to divide by 3, we're going to divide by 3, we're going to get the absolute value of 2x plus 4 equals 8. Now we actually have the absolute value sign by itself. We're going to go on to step 2. Check if answer is negative. If it's yes, no solution. If it's no, move to step 3. So the answer is no, it is not negative. So we can move on to step 3. Step 3. Make 2 answers and solve. So we're going to make 2 answers and solve. So what we're going to do is you're going to write this twice. It's 2x plus 4. Nothing changes to that, so that's written twice. But what we set them equal to is a negative 8 and to a positive 8. Oh. So what we're going to do is you're going to solve both of these equations. So you get 2x equals negative 12 divided by 2. X equals negative 6 is one of your answers. For the second answer, we're going to do the same thing. We're going to subtract 4. You're going to get 2x equals 4. You're going to divide by 2. You get x equals 2 as your second answer. Now on to the next one. Same idea. Step 1, get the absolute value sign by itself. So we're going to first subtract the 8 from both sides. This becomes 7 absolute value of x minus 6 equals 49. Then we're going to divide by 7. So that's going to give us x minus 6 equals 7. Okay. Step 2, check if answer is negative. No, it's not negative, so we can move step 3, make 2 equations. X minus 6 equals negative 7, x minus 6 equals positive 7. Okay. Then we're going to add 6. This is the solving part. So now we get x equals negative 1. And we're going to do that to the second equation. Add 6, x equals 13. So we have x equals negative 1 and x equals 13. Finally, the last one. We subtract 10, we subtract 10. We get the absolute value of 5x plus 7 equals negative 2. Okay, now this is where the step 2 comes in. Check if your answer is negative. The answer is yes this time. The answer is negative. So there is no solution. Now down to these. Okay. Step 1. Get the absolute value or square term by itself. Well, first let's add 9 to both sides. That equals 4x squared equals 196. Well, then we divide by 4. We get x squared equals 49. Alright, so now this is step 3. Step 2, check if answer is negative. The answer is not negative, so step 3, make 2 answers and solve. This is pretty easy because we had to square root both sides. And you get x equals -7 and +7. Those are our 2 answers. We didn't actually have to really solve because x isn't really next to anything. When we get down to this last one, we will have to actually employ step 3 more. So this next one, we're going to subtract 9. We're going to subtract 9. This is 2x squared equals 144. You're going to divide by 2. You're going to divide by 2. You get x squared equals 72. Okay. Now if you put this in your calculator, I don't know what you really get, but we are just going to say x equals negative square root of 72, positive square root of 72. Whatever you guys get that in your calculator, that's the answer. I kind of screwed up because I guess I didn't think about the 2, so I should have thought about that when I was making this equation. Alright, the last one. I'm going to add 6 to both sides. So it's going to be 2 times x plus 2 squared equals 18. We're going to divide by 2. We're going to divide by 2. You get x plus 2 squared equals 9. Now we get into this whole making 2 answers thing. This is positive, so we have to square root both sides first. That's how you get rid of this squared term right here. Now, square rooting something when you have a variable gets you 2 answers. It's going to give you a positive and negative of whatever the square root is. The square root of 9 is 3, so it's going to give us -3. And it's also going to give us +3. So, what we do with that is just solve like normal. We would subtract 2, x would give us -5. Subtract 2 on both sides, x would give us +1. And that's how you would solve these type of equations. Sorry, I just forgot to circle all my answers. Yep, here, let me... Okay, good. Alright, this next one is graphing. Okay, so this is an absolute value function, so this is going to make us a v. How this makes us a v is first we always look at this. This is the h. The h is always the opposite of whatever's on the inside. So the h is going to be a -5. So we're going to put a -5 in the middle there. We're going to put 2 numbers that are smaller than it. -6 and -7 are smaller. -4 and -3 are bigger. So then we're going to put those 2 on there. Once we've done that, we're going to plug each of these in here to solve to see what we get. So the first one's going to be the absolute value of -7 plus 5 minus 2, which equals the absolute value of -2, or -7 plus 5 is -2 plus 2. When you do that, what you end up getting is 2 plus 2, which equals 4. Now you do the same thing over here. You would do -6. Oh shoot, should be minus, so this should be a 0 actually, sorry. It's a value of negative 6 plus 5 minus 2, which equals 1 minus 2, which equals negative 1. And then this one will go to 0, this one will be negative 1, and this will be negative 2, because if I did the same thing, that's what I'd end up getting. Now if I graph this, it could be negative 7. Whoops. Hold up. Negative 7, 0. Oh, my bad. This should be negative 2. Negative 1, 0. Okay, negative 7, 0. Negative 6, negative 1. Negative 5, negative 2. And your graph should end up looking like that. Now this one over here, I'm not going to do much. I'm just going to give you the x, the y. You start at 2, so 2, 1, 0, 3, and 4. So it's going to be 1, negative 1, negative 2, negative 3, negative 2, negative 1. Okay. So if you plugged each of these numbers in for x and solve, because remember, absolute value, what it does to a number is it makes it positive. So 0 minus 2 is a negative 2. The absolute value of that would be a positive 2 minus 3 would make us negative 1. 1 minus 2 is negative 1. The absolute value of negative 1 is a positive 1. Minus 3 would give us a negative 2. And that's how that would work. So you get 0, negative 1, 1, negative 2, 2, negative 3, and that's how that would work. Now these, you do the same exact thing, and it'll come out with pretty much the same type of outcome. So negative 3, it's positive 3 is where we start. We do 2 less, 2, 1, 4, and 5. So now we've got our 5 numbers we want. Each of these numbers we plug into here. So the first one we do 1 minus 3 squared plus 2, which ends up being 4 plus 2, which equals 6. Now let me explain why it's 4 plus 2. Okay, so 1 minus 3 is a negative 2. Now that squared, anything squared is it times itself. So if you have a negative 2 times a negative 2, that's a positive 4. That's how we get this positive 4. And then adding 2, we get 6. Do the same thing with 2. 2 minus 3 squared plus 2. It actually is 1 plus 2, which equals 3. Because it's going to make us negative 1. That squared is 1 plus 2 is 3. This is going to end up being 3 minus 3 squared plus 2, which equals 0 plus 2, which equals 2. And this just ends up being the same thing again. You'll notice if you guys do not get numbers 6, 3, 2, 3, 6, if you don't get numbers like that, we did something incorrectly. Because you always have to, it should always go down then back up. The last one made a V shape, this one should make a U shape. So I'm going to first go to 1, 6. 2, 3, 3, 1, so on and so forth. It should look something like that. Now this next one, I'm not going to do all of that. Actually, I will. So, we do not have an h here. So our h is actually 0. So it goes 0, -1, -2, 1, 2. And once again, all we do is plug this in. So this becomes -2 squared plus 4, which equals 8. This one becomes -1 squared plus 4, which equals 5. 0 squared plus 4, which equals 4. 1 squared plus 4, which equals 5. 2 squared plus 4, which equals 8 again. So notice once again, all I did was square the number, then add or subtract whatever's behind it. So if I graph all this, -1, 5. That's all I did. Okay. This next part. Find the equation of the following. Describe the transformation, i.e. movement on the x and y axis, and any stretching or shrinking. Okay. So first, stretching and shrinking. -1 to 1 is a shrink. Anything outside of that is a stretch. And when we're talking about this, we're talking about the numbers in front. Okay? So this first one, this is a square root function. The h equals -7, so move left 7. K equals -6, so we're going to move down 6. And last but not least, is it a stretch or shrink? Well, it was a shrink because it's between -1 and 1, so it's going to be a shrink. The next one. This is an quadratic. The h is -3. So move left 3. K is -4. Move down 4, because the h is always opposite, the k stays the same. That's why we keep getting the same h but opposite h's. I mean same k but opposite h's. And finally, this is a stretch because 5 is in this range. Last but not least, this is an absolute value. H equals -5, so we went left 5. K equals -8, so we went down 8. And last but not least, it's a shrink because 3/4 is less than 1. next one. Okay, so we know this is square root. Which means it is f of x equals a square root x minus h plus k. So we know that. Now, our h goes off of this. Okay, so our h gives us 3. Our k gives us 2. I know this looks like a negative, but these aren't actually negatives because I cut it off too early. So it's actually a positive. H and k, and then finally our a, we go up 1, or we go over 1, 2, 3, 4, 5, 6, 7, 8, 9. So our a equals 1 over 9. But with square roots, there's a special rule. Square roots the run. So we're going to square root this part, which means it's going to be 1 over the square root of 9, which equals 1 over 3. So when we put this in our equation, it becomes like this. I'm going to do this. It's going to be f of x equals 1 over 3 square root x minus 3 plus 2. So that's what our equation is. So now we know it's a square root. We know that it moves right 3 because of this. The h is 3, so it moves right 3, and it moves up 2. Okay. And then finally, this 1/3 means it's a shrink. And that's how you find a square root function's stuff. Now this is a quadratic. Okay, we know that its little thing is f of x equals a times x minus h squared plus k. We know that the h equals -2. The k equals -1, so this is going to be left 2, right 1, not right 1, sorry, down 1. Now we have to find our slope, or a. A equals, if we go up 1, 2, 3, so we went up 3, we went over 1. So that's 3 over 1, special rule. Square run. So because it's a quadratic, we square the run, which equals 3 over 1 squared, which is just 3 over 1 still, which just equals 3. So when you write this equation, it should look like this: 3x plus 2 minus 1. and this is going to be a stretch. Now, the reason why it's plus 2 is because if we put this into here, the negative 2 and the negative sign in front of the h would end up making it positive. The next one, the absolute value. So h comma k, top 1 to over 1, 2. Okay. So the absolute value which is f of x equals a times x minus h plus k. So our a equals 1 over 2. No special rule. H equals 2, so write 2. Our k equals 3, so it is up 3. So the whole idea is like, how far did this move? So it went right 2 and up 3. That's why we keep saying these right, left, up, down, because if it's a negative number, we started here, we'd have to move to the left. If it's a negative number in the k, you'd have to move down, so on and so forth. That's all this right, left, up, down means, is that we're moving up, down, left, or right from this point where the parent function technically started. So if I filled all this in, you get f of x equals 1/2 x minus 2 plus 3. And this one would be a shrink as well. Now this one down here, it should be a lot easier than it looks to actually do. To do the reflection, all you have to do is make everything positive. So do you see how this is negative? It becomes positive. X plus 5. And the 3 behind it is positive, so that becomes negative. From there, to do a reflection across the x-axis, all you gotta do is this, is you gotta count. This is 2 spots from negative 6. So I'm going to count 2 spots from negative 6, and I'm going to put another dot. This is 1, 2, 3, so I'm going to count 1, 2, 3, and I'm going to put another thing. This one is 1, 2, 3, this is going to be 1, 2, 3. Now, if you don't remember this on the test, technically you could take this, and you can do the x, y, t chart and solve. But this is a lot easier just to show it like this. That is the reflection. That's how it reflects across the x-axis, because it's equal spaces from the x-axis for both of these things. Same thing over here. I have 3 points. Count 1, 2, 3, 4. So I'm going to count 1, 2, 3, 4 and put a little dot. This is 1, 2, 3, 4, 5. So we're going to count 1, 2, 3, 4, 5. Same with this point, it's going to be 5 away. From there, all I got to do is make my little, and as you can see, that's what the reflection across the line would be. This up here, to actually show the equation, this is the positive 2 becomes negative 2. Guy on the inside does not change, he doesn't care about any of this. And then this becomes a positive 6. Now technically, you know what, I just realized these are different problems. So, That's how you do these two problems, and that's how you do these two problems, and that's how you show a reflection across the line. You technically do not need to do the equation for these. So that's how you reflect when you have a graph, and this is how you reflect when you have a regular thing. Alright, well, so that's it. Hopefully you guys studied for your test, and I'll see you guys tomorrow.